Hello class, I hope all is well for you wherever you are doing this video. Welcome to lesson 13, tables, equations, and ratio value. Today before we jump into the lesson, we're going to start a new technique. I've heard that these videos can sometimes be a little hard to see on small screens like phones. So we're going to change up the format a little bit. At the beginning of each video, I am going to cut the screen in half, do it wide screen version like most screens are designed these days, and give you the opportunity to pause the video now and copy the first half. Next, slide it up and you can see the second half of the notes. Hopefully this is a little bit better for you on those small screens, and if it still is too small, then we can split it into thirds next time. Just let me know. Now would be a good time to pause and do the second half. Okay, hopefully you're back and you are listening. We are looking at the full page now, all together, and we'll zoom in when it's necessary. Lesson 13, like I said, deals with tables, equations, and ratio value. Tables and ratio value are things that hopefully we should be pretty used to by now at this point. A table is just a way to organize your ratios, and the ratio value, if you remember, is, you just take whatever your ratio is and you turn it into a fraction. Now, that's a little bit of review. Let's jump right into our new lesson. So, the question we are going to seek to answer by the end of this lesson: how can I use ratio values to create equations? Now, equations here is kind of a scary word. It's a new one that we haven't looked at. But don't be too intimidated, though. We should be just fine by the end of this lesson. I will warn you, though, it is pretty tough, and we'll practice it a lot in class. In order to solve this question, how can I use ratio values to create equations, we're going to perform a task. First off, we need to identify the order and create fractions. And when I say identify order, I'm highlighting that for you because if you think back to the first or second lesson when we started talking about ratios, we said that the order matters. You can't just flip-flop the numbers and expect it to mean the same thing. So when we are looking at creating equations for our ratios, we have to make sure we're looking at the right order. So let's come down here to our first example. Example number 1. The ratio of length x to the length y is 3 to 5. So we are looking at two lengths. Those lengths are length x and length y. You know that the 3 is your x value and the 5 is your y value. Okay, and down here below that, we have shown three different examples of how you could use this information of x to y is 3 to 5 and create some fractions as ratios. So if we're looking at this first one, we see length x is 3/5 of length y. Okay. Now if this sounds familiar to you, that's good because we've done this already. We have looked at ratios and turned them into fractions. Okay? Just like we're doing here. If we're looking at the length of x is 3/5 of the length of y, all we're adding to that today is we're turning those into equations. Okay, these things over here are our equations. And we'll get to that soon, but I want to keep going through our examples. So, length y is what we're starting with. So length y is the first value you see is 5/3 of length x. So if you are looking at just these two examples, these top two, you know that our x comes first, so it's going to go on top. Our y comes second, so it's going to go on the bottom. And if you look down here at this second example, length y is first, so it's on top. Length x is second, so it's on the bottom. Now here on our third example, I made it a little tricky, but we're going to be seeing a lot of this on our classwork. We throw in a whole new value. We're not just looking at 3 or 5, but we're looking sometimes at the total length. All right, so you need to know in the back of your mind, we're not just looking at two numbers, 3 and 5. We're also looking at 3, 5, and the total, which would be 8. Always have that in the back of your mind, knowing what the total of the ratios are. So, if we here are looking at length y is 5/8 of the total length, yet again, y is our first value that we see, so it's on top. The total length is the second value that we see, so it's on the bottom, 5/8. So we'll zoom back out here so you get the whole picture. Now, I'm going to show you this now and explain to you how it can be very, very easy in just a moment when we look down at the bottom of our page. But each of these sentences, length x is 3/5 of length y, can be expressed as an equation. So this is the corresponding equation to our first sentence. X is 3/5 of y. And we see that same principle here. If we are looking at the length, sorry, try and get my little pointer finger back. Let me go. The length y is 5/3 of the length x, then here we have y is 5/3 of x. Okay? And the same thing here. The length y is 5/8 of the total length. Y is 5/8 of the total. All we're doing is we are taking these words and turning it into math figures. Okay? Now you should be pretty used to that because that's mostly what we do when we do word problems, is we change the words into math numbers that we can use. So we'll scroll down here and do another example using a chart, or a table rather, I guess. Here we have a list of equivalent ratios. We have 1 to 3, which is equivalent to 2 to 6, 3 to 9, 4 to 12, 5 to 15. They are all equivalent ratios. Now, if I wanted to figure out, let's say, for example, I wanted to know the, let's say the amount of girls is what fraction of the amount of boys. Okay, so what I would do there is I would look at which of those figures comes first, and that is girls. So my first digit will be, or my numerator will be 1, because that's the first. And my denominator, since my second figure is boys, my denominator will be 3, because we have 1 girl for every 3 boys. Okay? Now, if we come over here to the side, we see that, I guess I can get rid of this. We see that if we follow, we have 1 girl for every 3 boys. And we knew that this ratio of 1 to 3 as a fraction is 1 over 3, because the 1 comes first. Girls are 1/3 of the boys. Okay, so there are less girls, so there's 1/3 of the boys. If we come down here, our second ratio, 2 to 6, Okay, it's the same thing. Our fraction would be 2/6, which is, it really simplifies to 1/3. Okay, now that has to do with ratio value. All equivalent ratios have the same value. But let's say if we look here for this equation, which comes first? The B comes first, right? We see boys. So if we were to write a sentence for what the boys is, it might look something like this. Oops. It might look like the amount of boys is what fraction of the amount of girls? That's what we're going to try and figure out. Amount of boys is what fraction of the amount of girls? So, yet again, let's take a look. The boys comes first, so the boys is our numerator. And the girls comes second, so the girls are our denominator. Oops, there's not two girls. What was I thinking? There's only one girl for every 3 boys. So if this is our value of boys first and girls second, which it should never be that way. Ladies should always go first. However, if that's our value, 3 to 1 really just equals 3, right? So let's come back here. The amount of boys is 3, because 3 is the same thing as 3 to 1. The amount of boys is 3 times the amount of girls. Okay? And so on, we have down here. This is just kind of another way of illustrating this fact. The girls, actually, let me get rid of some of these things, get them out of the way. So, the girls is on top, boys on the bottom. So girl is 1, boy is 3. So if we're looking at girls to boys, we have 1 to 3. If we're looking at boys to girls, boys first, girls second, we have 3, because really we know that it's actually 3 to 1. But 3 to 1 can be simplified as just 3. Now here's the bonus information I wanted to share with you earlier, and this will be super, super valuable when you move on to algebra and algebra 2 and higher level math. You want to learn some shortcuts as to how to translate words into math symbols, because that can get tricky. So, bonus info, whenever you are translating words to math symbols, listen to this. It's super important. The word is will always become an equal sign. The word is will always become an equal sign. Whenever you see the word of will always, always, always mean multiplication. Multiply. Every time. So, if we want to put that into play and sort of recap and, make sure Mr. Fields isn't a liar, let's take a look up here. All right? We have length x. Length x is, what did we say is means? We said is means equal sign. So if I circle this in red, is, over here in the equation that corresponds, is means the equal sign. Okay? X stays x, is the equal sign. Then let's say our fraction stays the same, because the fraction can just be what it is, 3/5. And then our y stays the same, but we won't get to the y yet. Let's see, let's circle our of, because the of always means multiply. So, like I said before, whenever you see a number butted right up next to a variable, it just means multiply. So I drew a little x in there, which means multiply. And then last but not least, our y will stay the same. And our y, let's just make that orange. Oops, orange. y stays the same. So you can see, I know that's a lot of colors and probably kind of confusing, but you can see that is will always become an equal sign, and of will always become multiplication. Let's slide back up. Is always means equal, of always means multiply. Then all you have to do, all you have to do, get rid of this thing, is read straight across your sentence, length x, so bring your x over, there it is, so bring your equal sign over, there it is, 3/5, bring that over, of means multiply, y, bring that over. We will get plenty of time to practice this in class. I hope that's not too confusing for you. We'll take a look at it with our classwork and practice until it just becomes second nature. I promise you, it blew my mind when I first learned it, and now it's just basic mental math. You will get it. Trust yourself.